Okay, we're going to be looking at how to graph conic sections. And when we talk about conic sections, essentially conic sections come from the concept of taking a cone. So I'm going to try to draw some cone here. This is supposed to be a cone. And the word section really means to cut. So if we cut this cone in certain sections in certain ways, what you'll obtain are the following shapes here. A circle, an ellipse, hyperbola, and a parabola. So what we already worked on, though, is graphing parabolas. I'm double checking something here. All right. So, of course, this typing is crazy. And our ellipse has two L's, so you guys know. Anyway. So these are shapes that we get when we actually cut a circle. A cone. And let's see if I can shrink this up a bit. So these are, yeah, there we go. That's a lot better. So anyway, if we cut our cone, with a plane across this particular shape, we're going to get these following graphs: circles, ellipse, hyperbolas, and parabolas. We already knew how to graph parabolas. We talked about that. We had the graphing form. We have y is a x minus h squared plus k. Here's the graphing format for the parabola. So what we're going to go through here is the graphing format for some of these other shapes. For example, we're going to start with a circle. The general equation of a circle, your graphing format here, is x squared plus y squared is r squared. And r here is known as the radius of your circle, and your radius is positive here. And I want to say that this circle here is centered at the origin. And so where this actually comes from, in case you didn't know, and let's see if I can find my graphing picture here. Photo library. Yeah, let's look at the, gonna find, there we go. I think we can find this, I hope. This one is okay. I think I did have that. We can draw our own, or we can actually use this one. Thought I picked this one. That one. Insert photo. Okay. Now let's see here. Hopefully this one is okay. So where this comes from, so you guys know, it comes from geometry. That the distance here, here's some point. We'll call that xy. And here's another point. Here's your origin at 0, 0. If you recall the distance formula, this distance called d from geometry, we have the distance formula being the square root of the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's the distance between 2 points. So we're going to call that d, the distance between 2 points. And in this case, our first point is, I guess we should say the origin. We'll call that our first point, the origin. And the second point we're going to call this arbitrary xy. So your distance formula d here is going to be applied. And what that means is, let's plug the values in. So this is x, this is y. And then we have 0, and we have 0. Because we're using the distance formula from geometry. So we get now that d is the square root, and that's x minus 0 squared plus y minus 0 squared. So then d becomes the square root of, and I think we knew that, right? What we do here is, it doesn't know we want to do a square root sign, so we can't assume that. So we got x squared now plus y squared, because you're doing the arithmetic here in the parentheses, right? You're taking that difference, taking that difference. And so now you know from this course, intermediate algebra, what we end up here with is this x squared plus y squared. We're going to square both sides. Square the left side, square the right side, and then, ladies and gentlemen, you obtain d squared is x squared plus y squared. And we'll read this way. X squared plus y squared is d squared. Remember, if Jennifer Lopez is J-Lo, then J-Lo is Jennifer Lopez. And what you'll see here is a relationship between the coordinates x and y and this value d called the distance. And it's actually, notice they're all squared here. So the powers are all 2, even for d. Okay, so go back here. You said, well, what was d? Well, d here is this distance in blue from the origin to some arbitrary point xy. And that distance is a constant distance. So if I were to say to you, and I'm going to try this out. I'm not sure if it can do this. I think it should be able to do a circle, ladies and gentlemen. There we go. There we go. Let's adjust the size of our circle. There we go. So I'm going to try to make this. There we go. So what we're seeing here in this circle, you're seeing all these points, x and y, along that circle have the arbitrary coordinate, x and y. And the distance each one of them is to the origin is that value d. So that's a fixed distance d. That's constant, so you guys can see that there. And so what this traces out is a circle. So instead of calling that d for distance from the geometry formula, because remember, distance is always positive here. So they're going to assume here that d is greater than 0. Your distance is positive. And that means instead of calling that d, they call it r for the equation of the circle centered at the origin. So replace this d with r and say that r is positive. Ladies and gentlemen, you end up with the equation of the circle. X squared plus y squared is r squared. And that's centered at the origin with radius r. So that's kind of the derivation of where this comes from here. And so we're going to start to graph some of these things. So here's your equation. This is what you want to know. They're going to give you an example. And they're going to say, graph the following. X squared plus y squared equals 4. And what you want to do here is the following. I'm going to say step 1. Determine the radius. And it's called r. Determine your radius r. So if you have x squared plus y squared is 4 here, what you say is this value must be r squared, because this is the equation of a circle centered at the origin with a particular radius. So you're always going to find that value. You're going to say that value here, r squared is 4. And if r squared is 4, you're going to use the square root formula to find r. So r will be plus or minus square root of 4. Or r is plus or minus 2. Remember, your radius must be positive. So that means this circle has a radius of 2. So you found the radius here. And that's your first step. Find your radius. The second step here is going to be, say step 2, use the radius r to sketch a circle. So I can kind of get in, maybe we're going to look at that second step here, right? The radius here is 2 for your circle. Maybe we can add here that not paper. We want to add, not that. Was it photo library? Is there like a recent? Hopefully there's a recent. No, all these graphs I've had, ladies and gentlemen. So let's find the graph we needed again. Did we pass it? Yes, here we go. We're going to use that. Insert this. And let's see, we can make it kind of that big here. All right. Now remember, the radius here is 2. And we say, well, how do we use the radius? You're going to start at the origin, ladies and gentlemen. And you're going to go to the right 1, 2 units. There we go. You're going to go to the left 1, 2 units. You're going to go to up 2 units. And you're going to go down 2 units. Okay, so here's where positive 2 is. Here's negative 2, negative 2, positive 2. So you start at the origin and you go simply left and right 2 units and up and down 2 units. These are locations on the circle, all these points. And so what I'll try to do now is draw a circle. And let's try to see what happens. There we go. That's pretty good. I like that. And that looks like we might have a radius of 2. Maybe that's a little bit shorter. Anyway, we'll go with that. So, as you guys can see, the formal points 2, 0, negative 2, 0, 0, 2, 0, negative 2. These are all locations on your circle. And this is how we sketch our circles, centered at the origin with radius value 2. So what's going to happen for each one of these is all they're going to do is change the radius on you. You're going to change those radius values. So, another example. They can give you, x squared plus y squared maybe is 16 here. And they want you to sketch the circle. You always start by letting r squared here be 16. You're going to let r squared be this number here. And you solve for r, where r will be plus or minus the square root of 16. And you guys know the square root of 16 is 4. So that means r is plus or minus 4. It really means the radius is positive 4 because it's defined that way. You don't have a negative radius. So again, this is our first step. We have to find the radius value. R is 4. And really, you identify the curve here. You can say, I got x squared plus a y squared, and that equals some constant number. Well, that's the equation of a circle. So you identify the curve by looking at it. And that's how you go about this. So anyway, let's continue. You say, well, how do I graph? Well, we're going to go to the photo library. We're going to insert this. And there you go. Hopefully you guys can see that. Okay, here's our Cartesian coordinate system. Remember, the radius is 4. So we're going to go start at the origin. We're going to go to the right. 1, 2, 3, 4. And I guess we can stick with blue. How's that? Or red, doesn't matter. 1, 2, 3, 4. That's the point, 4, 0. From the origin, go to the left 4. 1, 2, 3, 4. That's the address, negative 4, 0. So you're going through negative 4 there, and it's on the x-axis. These are your intercepts, by the way. But this is a circle, so you go up 1, 2, 3, 4 as well. And that address is actually 0, 4. And then you'll go down 1, 2, 3, 4. And that'll be 0, negative 4. So all these here, what you really found are the intercepts, right? You found the x-intercepts for the circle. They're on the x-axis. And you actually found the y-intercepts here too. They're on the y-axis. Just draw your circle. And there we go. I like that. And can I make it fit? I guess it's a little bit. We'll call it good. There's your circle. Circle of radius 4. And so all these, values on the circle, these coordinate values, x, y, satisfy the equation of a circle. And this is how we go about sketching, ladies and gentlemen. So we're sketching circles. Centered at the origin. And then, for example, I might say to you, x squared plus y squared is 1. Now, this is called the unit circle. So this has a very special name. This is our unit circle because the number 1 really means unit. So r squared here in this case equals 1, which means r is plus or minus square root of 1. R is plus or minus 1. Our radius is 1. So here's how we start. So we have to draw a circle with radius 1. So if we start to do this picture again, let's try that out. Let's find, not paper. Let's put a photo. We're going to get our Cartesian coordinate system. Oops. Here we go. And because it is in the middle of a page, it doesn't like to do there. It wants to go to, there we go. Okay, that's fine. It seems to be a little bit easier for us to do. So remember now your radius is 1. So from the center of the circle, from the origin, just go to the right one. Here you go. Go to the left one. Go up 1. Go down 1. These are all locations that are on your circle. They're really the x and y intercepts. And formally, 1, 0 is the address. Negative 1, 0. 0, 1. 0, negative 1. So don't forget, sketch the circle. And it looks like I'm going to try to make that smaller. And okay, we're just going to go with that. All right, hopefully that looks okay. I would try to move a little bit to the left, but you guys get the idea. There it is. There's your circle centered at the origin radius of 1. Just like here, your radius here is 4. And up here, the radius here is 2. And so on. So this is how we sketch circles, ladies and gentlemen. Okay, let's give you a tricky one. Example. X squared plus y squared, we're going to say is 12. Okay, 12 here. Now, you might say, do we start by letting r squared be 12? Now say yes. So then by the square root formula, r is plus or minus square root of 12. And you say the radius has to be positive. It does. And when you simplify the square root of 12, ladies and gentlemen, you're going to get, if you remember, this is going to be 2 square root of 3. So go through your simplification process here. And what you notice is you have an irrational number. All right, so this is an irrational number. And so you might say, okay, Mr. Judge, how do I do this? How do I actually plot this? Well, you know what you could do? There's a couple of things you can do. One thing I can say to you guys is, if you draw here your x and y axis, and without some of these natural features, drawing straight lines, I don't know what I do, but you can do this symbolically. So there's a couple of things we can do. We can say, hey, I know if I start at the origin, I got to go to the right 2 square root of 3, whatever that is numerically. So I'm just going to do something like that. I'm going to say, guess what, ladies and gentlemen, that's 2 square root of 3. Now go to the left the same kind of amount of distance, because it has to be the same, but it's in the negative direction, remember, on the x-axis. And I'll do the same thing up and down. So there we go. 2 square root of 3. And so you're actually just kind of sketching, so long as you make these distances here from the origin, right, to these values the same. They have to be the same exact value, because that's what a circle is. And we're just eyeballing it. We're just sketching it. And when you sketch the circle now, we're going to try to fit it here. As you can see, even though I eyeballed it, you know, it's not so accurate, but it's close enough. This is just a sketch where you do have formal addresses of 2 square root of 3, 0, and negative 2 square root of 3, comma 0. This is 0, 2 square root of 3, and this will be 0 minus 2 square root of 3. So ladies and gentlemen, here's your equation of the circle centered at the origin. Radius is 2 square root of 3. Now this is what you can do. Another thing that you can do is you can really approximate now if you want. Go back to 2 square root of 3. This is an irrational number. You can approximate this. And so approximate to the tenths here, because we're just going to sketch, meaning 1 decimal place, tenths. We got to approximate 2 square root of 3, so we're going to need a calculator for that. So I'm going to have to look for a calculator here And here we go. Here's a calculator. Let's see. Not now. Let's see if this one's any good. Do I have a square root here anywhere? I don't know if I like that calculator. So let's get out of this calculator. Right? I don't like that calculator. I want 2 square root of 3, so I think I have another one here somewhere. I don't know. Do I like this one? I think I like this one a bit better. So here's 2, and now we need the square root of 3. Here we go. Square root, put the 3 there. Hit enter. So what you see, ladies and gentlemen, is 3.4641016154114. That's an irrational number, meaning that that decimal never terminates, even though it's terminating here in front of you. It's just because of the memory of this particular program only goes so far with digits. It's numerical accuracy. So it looks like it's terminating, but it's not. And then there's a random distribution of digits there. So anyway, we're going to approximate this to the first digit, that 4. That's the 10th position. So I look to the digit to the right. It's a 6. So because it's a 6, if that digit was a 5, 6, 7, 8, or 9, we add 1 to the 4. In this case, it's a 6. So what this will mean is R here is approximately 3 point, well, it was 46, right? So it's going to be 5. Remember this? 3.46 something. Put your eyeball on the 6. That means to add 1 to the 4. So it's about 3.5, ladies and gentlemen. So this is another way we can do this. We can approximate this so that when we sketch this curve, as you guys can see, 1, 2, 3, 4, we're not as accurate as the sketch. And that's okay. This is another way of doing it. So what I'll do here now, maybe in red, so you can compare and contrast. Go to the right, 1, 2, 3 and a half. Go to the left, 1, 2, 3 and a half. Go up, 1, 2, 3 and a half, and go down, 1, 2, whole units. Oh, let's undo those last 2. There we go. Let's go down, 1, 2, 3 and a half. So when I draw my circle, ladies and gentlemen, I'm going to try to draw it in such a way where I go through those points here. There we go. Oh, I moved. There it is in red. So in blue, you actually have just a rough sketch, right? It's not to scale. So I'm going to get rid of this in blue. That's one way we can do it. Get rid of the blue. And another way we can do it is actually to approximate the values for R using a calculator like we just did. And now we have R, the radius is actually more accurately approximately 3.5. And this is a way we can actually, sketch this curve. So, ladies and gentlemen, if I want to point the formal locations of this, 3.5 comma 0 for the intercepts. Negative 3.5 comma 0, 0, 3.5, and 0, negative 3.5. These are the locations, and this is another way to sketch a circle here. And that's a circle centered at the origin now. Now, we're going to focus first here on these conic sections centered at the origin. And I'm going to tell you here, we have another conic section called an ellipse. And the equation of the ellipse is x squared over a squared plus y squared over b squared. And this equals 1. And what I'm going to show you here is it has a center at the origin, and A is not the same as B. So these values are not the same. And if you actually look this up, and I can't show you here, usually we can go online together and I can show you this ellipse and where it comes from. It would be nice to do that. Let's see, how do we do this? Maybe we can do it. No. I think that there is a great picture that I'm looking at here of a conic section. How do I import this into, how do I share this? Is there a way to share it? It's a beautiful picture. Beautiful picture of the conic section. Oh, there should be a way where I send it to myself as, I don't know, AirPlay. I don't know. Anyway, I wish I could share this. How do I do that? You know what? Couldn't I do this? How about, let me try something here. Share it with you guys. I'm going to try to see if I can email that, but let's email that to myself. There should be a way I drop it into, I wish there was a way I could drop it into my iPad. I'm going to call this Ellipse. And we're going to send that to ourselves here. And you can hear that. And let me double check here. We don't want the Venetian. There we go. There it is. There you go. That's the beautiful picture of the ellipse. Told you take a cone and you cut it. All right, let's see if you guys can see that one there. Told you do that. There's my ellipse. Let me see. What I want to do is make that bigger. Is there any way to go back and make it bigger? Thought there was a way. Well, okay. Here's the ellipse, ladies and gentlemen. It's in red. And as you can see, I take a plane and I cut this cone and I create this ellipse. Nice picture. Wonderful picture. Notice on the bottom, if I cut with a plane, I should say horizontally down here, let me point this out, right? We get the circle we're talking about, right? So here's the cut for a circle. And in red, this is the cut for the ellipse. And that's what we're talking about. So we're going to sketch this. And the equation of an ellipse is x squared over a squared plus y squared over b squared, and that will equal 1. So this is where the ellipse comes from. Now, that's a beautiful picture. I love that. Anyway, okay, let's look at an example here. They want us to sketch this curve. We have x squared over 16 plus y squared over 4 equals 1. So what you have to notice is a couple of things here. You got to notice you have x squared and y squared, and they're both over constants. Okay, so in this case, the constant under x squared is called a squared. And the constant under y squared is called b squared. In other words, numbers here. And you must have addition, and it must equal 1. So these things must be there. And this is the equation of an ellipse. So your first step, like you've seen before, step 1. We're going to let a squared be 16 and b squared be 4. So you let a squared be that number, let b squared be the other one. So I'm just going to give you it in words. I'm going to say, really? Here's what we're going to say. Determine the values of a and b. So you're going to find those numbers. We don't know what they are, but you're going to locate them. You're going to find the values. And then you say, well, how do you find the values, Mr. Judge? Well, what you did before. A squared is 16 down here. This is your a squared value. And then similarly, you're going to say b squared is 4. The value of b squared is this number here. So solving for a and b, we're going to use the square root formula. A will be plus or minus square root of 16, which means a is plus or minus 4. And there you go. We got the a values, and we're going to use both values here. A can be negative. Solving for b, b is plus or minus square root of 4, which means b here is plus or minus 2. So these are the a and b values here that we look for. Okay, so we got these values. Okay. All right, let me do a couple of things here. And you may say, okay, once we get these values, what do we do? So I'm going to say step 2. Here's step 2. You're going to plot the a values along the semi-major axis. You go, semi-major axis, oh my God. Okay, really just the x-axis here. All right? So plot them along the x-axis. And that's the a values. You're going to plot the b values along the semi-minor axis. You go, oh my God, Mr. Judge, what's that? Well, that's your y-axis here. You're going to plot that, okay? What you guys are looking at, in case you didn't know, these are really intercepts. These are where the curves cross both the x and the y axis. These are intercepts, ladies and gentlemen. That's what these things are. And then this is what we mean by that. You see, your picture of this ellipse will always look like this. I think what I'll do, ladies and gentlemen, I'm not going to bring that picture in. Oh, I'm not even going to bring your calculator in. We're going back here. To draw a picture of this for you guys in general, I think that's what I'll do. And we're going to sketch it like we did prior. And I don't like that. So let's do this. Okay, that's a bit better. And then the y-axis. There you go. X-axis, y-axis. Here's what I mean. Those a values are positive and negative in general. As a sketch, I'm going to put A over here. And on the opposite side, that's where negative A is. And then here, I'm going to have a B. And here, I'm going to have my negative B. So the A values that we're talking about, they're on the x-axis. And the B values, they're on the y-axis. Those are the values you found. In step 1, we found A is plus or minus 4. We found B is plus or minus 2. So we'll show you what this is. I'm going to try to draw an ellipse. Hopefully, yeah, it automatically goes to erase sometimes. Hopefully, I don't want to erase. Hopefully, let's try that again. This knows we're trying to draw an ellipse. It thinks it's a trapezoid. I'm sorry, not a trapezoid, a polygon. Boy, I don't know if I do this. Let me see if I do this. There we go. Nice. I like that. You see that? It knew we were drawing an ellipse. So I'm going to stretch this out. And if you say, hey, Mr. Judge, your ellipse kind of looks like an oval shape, right? Well, they do look a little bit oval, but it's not perfect. You know, so yeah, it's kind of interesting if we can find a way to tweak it. Maybe down. Does it go diagonal tweaking or just left and right tweaking? Anyway, okay, let's try to say that. There you go. It kind of looks like an oval shape. This is called an ellipse in general. That's why you find the A and B values. The A values, again, are right here. Here's my A's. Here's my minus A's. And the B values are over here. So you guys know. In the formal address, you go through A, comma, 0, minus A, comma, 0. Here we go through 0, comma, B, and 0, comma, minus B. So here is the intercepts, the x and y intercepts. This is really what they're talking about when they say sketch an ellipse. This is a general picture. In particular, you say what happens when A is plus or minus 4 and B is plus or minus 2. Well, I think what I'll do now is import the picture. And I went past it. There we go. Import the graph. Okay, there we go. Import this photo. And I guess we'll put it down here and stretch this out. Remember, A is plus or minus 4. So I'm going to look for A. Maybe we'll color it red. 1, 2, 3, 4 to the right. That's where 4 is. And then from the origin, go 1, 2, 3, 4 to the left. That's where negative 4 is. And then the B value is 2. So I go up 1, I go up 2. So we go, here's 2. Go down 2. Okay, that's where negative 2 would be. And I think we colored it different colors. So I don't want to highlight it. Here's my green. And here's the green, right? We colored it different colors. So here's where 2 and negative 2. These are the values that we found here. A is plus or minus 4, right here. And then B here was plus or minus 2. So we plot those points. And then we sketch our oval. We sketch our ellipse. That's what it looks like. It's really the shape of an ellipse. And so I'm going to do that here. And notice I'm going to try it like this. I'm going to say, here's my ellipse. And boy, does it know that. That is fabulous. There we go, ladies and gentlemen. That's the sketch of your ellipse. And, you know, one of the famous reasons, I should say, or one of the famous uses of an ellipse, so you guys know this particular shape that I just went through as a graph for you guys here, ellipses are special. They're so special. This is the shape of orbits for planets. Every ellipse has a point called a foci, and it actually has a couple of foci. And there's a way to find the foci. But here's an ellipse, and planets orbit. Let me get a blue dot, meaning Earth, and let's make a yellow dot for the sun at a foci, and the Earth orbits that sun, and the sun, of course, is a lot bigger. So maybe we should make that sun brighter. Hopefully you can see how bright that is. And then we're going to take that Earth and make it smaller. There's Earth, and now we have Earth going around the sun in an orbit. And actually all the planets orbit the sun in an ellipse where the sun is at a foci, one of the foci. There's actually two. But in other courses, you'll learn more about the details of the foci. In this course, we just learned how to sketch these curves, and these are at the origin. Here's an ellipse. So ladies and gentlemen, this is your process. You just follow the process. Find the intercepts, really the A and B values, and then sketch that oval-looking shape, which is really not oval. It's not oval at all, by the way. It's the form of an ellipse. And there's a geometric interpretation of it, and you get to see that in geometry, but in algebra, we just simply look at this algebraically. I'm just going to give you some more examples. How do we sketch this? So I'm going to give you another ellipse here. We have x squared is 9 plus y squared is, we're going to say, 36. And that has to equal 1. Remember, the equation of an ellipse must satisfy, must look like. You're going to have to learn how to read this. It looks like this. Okay, x squared over a squared, and it must be plus y squared over b squared. And, you know, we have to have these squares for these values. And it has to equal 1. If you don't have this, it's not an ellipse. So, ladies and gentlemen, in this example, the first step, and maybe I'll do it this way. I'll say, oh, this is my a squared in red on the x-axis, and this is my b squared in green on the y-axis. So the first step is to solve for a and b, meaning a squared is 9, which means a will be plus or minus square root of 9, which is a is plus or minus 3. These are the two values that we use. For the second equation, b squared is 36 right here. B squared is that number, 36. Just as for a squared, it was 9. So when we solve for b, b will be plus or minus square root of 36, or we say b is plus or minus 6. So again, if you said, can I just call that my x-intercepts? I'll say yes. Can't we just call this my y-intercepts? Absolutely. So this is your first step. You got to find those intercepts. The next step is we're going to have to bring another graph in. So I guess it's photo. And we go all the way down to here. Insert. And here you go. So let's find the intercepts again. The x-intercepts are at plus or minus 3. And we'll color them in red, plus or minus 3. So from the origin, I go to the right, 1, 2, 3. And I go to the left, 1, 2, 3. Okay, that's my x-intercepts. My y-intercepts are at plus or minus 6. So those b values represent the y-intercept. So I'm going to go up 1, 2, 3, 4, 5, and 6 here. Then I go down 1, 2, 3, 4, 5, and 6 here. So these are the locations of my intercepts. I can say here's a 6, a -6, +3, -3. So we're ready to sketch our oval. We're ready to sketch this ellipse here. So I'm going to do it this way. Nice. I guess it does. If there's a way, interesting. Look at that. It is diagonal. All right. Huh. So if I have to be careful then. Yeah, can I? Yeah, it looks like. See this here. We're going to try to draw this here. And I got to find a way. Is there a way to make this diagonal? Style? No, I don't think it's style. There has to be a way. Put here, duplicate, cut, copy, delete. Duplicate, cut, copy, delete. I want to rotate. Is there a way to rotate? Yeah. Oh, it takes two hands. It takes your fingers. All right. Well. Hey, I don't want to do that. Yeah, there has to be a way we get back in there. I don't know what this is. Sorry about that. We can do it again if you wanted. Oh, you go to cut. Did you go to cut? Or you could just hit it. You got to use 2 fingers. And let's make it thinner. Anyway, that looks like it's okay. A little bit of patience. So, ladies and gentlemen, there you go. That's all we need to do. Let's go back. There it is. Thought we lost it. Good. So that's how we sketch an ellipse centered at the origin, find the intercepts. And then let's give you kind of a tricky one. It's not that tricky. Give you another ellipse. Let's say x squared over 17 plus y squared over 2, and that equals 1. Or how about, let me change my mind. I really apologize. I'll say 7, and I'm just going to say y squared equals 1. Now, if you guys were in front of me in class, what I would ask you is, hey, is this an ellipse? And a lot of people are going to say, no, it's not an ellipse. And then I remind people, I'm going to say, I'm going to put this over 1. Now, remember, you have x to the second power, y to the second power. It's plus, and it equals 1. This is an ellipse. It's just that here's my a squared. My a squared is going to be the value 7. And in green, I got my b squared here, and that's going to be 1. So it looks like a tricky question. So we have here a squared is 7, which means a will be plus or minus the square root of 7, which means a will be approximated to the nearest tenths. We're going to go to that calculator. I'm going to say, I think it was this one. Yes. Clear. We need the square root. 7. And this is 2.64575131106. If we approximate it to the tenths, the 6 is in the tenths position. The digit to the right is a 4, so that means leave the 6 alone. So, ladies and gentlemen, 2.6 for A. And then similarly, you may say, what about the B squared version here? So we say B squared here is 1, which means B is going to be plus or minus square root of 1. It just so happens here we know the square root of 1 is 1, so we have the value for B. No need to approximate, because the square root of 1 we know is 1. Okay, so we found the intercepts. So if I go to now try to sketch this, let's see if we could sketch it here. Okay, I'm going to do x-axis. Do the y-axis, do a little sketch here. Remember 2.6. So I go to the right, 1, 2, not, this is where 3 is. 2.6 is kind of halfway, but a little bit more than halfway. That's what positive 2.6 is. Negative 1, negative 2, here's negative 3, and it's on the other side, negative 2.6, something like that. Not quite halfway, a little bit further. And then the B values are plus or minus 1. So B here is 1, and then B over here, this is negative 1, ladies and gentlemen. I plotted the intercepts. And what will happen now is we're going to go back. We're going to sketch. Sorry. We're going to sketch the ellipse. Let's try to do something like this. Maybe that'll be... Yeah, that might help a little bit. That helps. There we go. Let's not breathe. All right, if we pull it down a little more. All right, there you go, ladies and gentlemen. There's your ellipse. Take a look. So this is what happens when we sketch these ellipses here. And then now what I'm going to give you here, ladies and gentlemen, is the hyperbola. So let's see here in the hyperbola. Let me tell you what hyperbola is going to be so you guys know. Think of that as it's going to be a double parabola. And I'm going to try to find that here. Maybe if I'm lucky, I can get a nice picture too. If I'm lucky, I think Wikipedia had something. All right, well, let me do this. How about if I do this? Let me see. I'm going to try something here, right? Nope. Not Desmos. I'm going to put hyperbola. Maybe that'll work. And you go here. Let me show you. Here's a nice picture. And I guess we can say this too. I want to import this into, here's my hyperbola, double parabola. Add to photos. Open in background, open a new window privately, download link file, add to reading list, add to photos, share, put notability. Add here. Import. Done. Then I'm going to add this equation here because you actually have two types. It only looks like it gave you a horizontal type. We're going to start with the horizontal. So I'm going to do the same thing. I'm going to share to notability. conics, import. All right, whatever. Says it's done. It's done. Well, where are you? Oh, weird. Well, okay, there's the shape of it. I didn't want that shape, though. I wanted to bring in for you guys here this idea of cutting the cone. I'll do the rest there for you. You're going to cut the cone. There it is. There's your hyperbola. And it looks like it didn't bring the cone picture in. Anyway, all right. It's a double parabola. As you can see, here it is, 2 parabolas. All right. And let me show you how to get it. You got a semi-major axis, still the A values, and there's no semi-minor axis. You have an diagonal asymptotes and 2 parabolas. All right. And it was found by cutting that cone. I don't see it anywhere. So what I would like to do, if I could, can I get rid of it, please? Can I cut it? Can I cut it out? How about if we undo? There we go. We undid it. So life is good. Okay. Double parabola. Parabola. Here's the equation so you guys know. X squared over A squared plus Y squared over B squared. Sorry, not plus. This is how it changes. This is a minus, ladies and gentlemen. Okay? That's minus. So you must have, this looks a lot like an ellipse, but it's not. And you have this here, this minus sign. There's a difference, and it still equals 1. So it looks a lot like an ellipse, but the only difference is that negative sign here. So let's give you some steps. You're going to do the same steps as an ellipse. So I'm going to say step 1. I'm going to say here simply determine the values for A and B. So first step, you're going to find those values for A and B. This is for your hyperbola. And, you know, I guess we should start with an example. So let's give you an example. Okay, so I'm going to give you an example. So if they give you, let's say, x squared over 49 minus y squared over 9 equals 1. So there we go. Okay. So A squared, and we have B squared. A squared is 49, and my B squared is 9. So we're going to write that stuff down. A squared is 49. A will be plus or minus square root of 49. A is plus or minus 7. And then similarly, we have B squared is 9, which means B will be plus or minus square root of 9, or simply B is going to be plus or minus 3. So we found these values. Now, I'm going to say this to you guys. Step 2. Plot the values of A and B A along the x-axis and B along the y-axis. I'm not using language of intercepts anymore because this only has x-intercepts. I'll show you what I mean. So plot these values there. Okay. To create a box. So here's what we mean by that. I'm going to draw this here. And I guess I'm going to have to, I'm going to draw it this way here. All right, we may have to sketch this. In other words, this may not be to scale. I'm going to sketch it. So here's the x-axis. Here's the y-axis. X-axis. Y-axis. So here's kind of what it looks like, right? So I'm going to plot the A values here, plus or minus 7. Let's see if we can draw it to scale. 1, 2, 3, 4, 5, 6, 7 here. So, okay. Here's where 7 would be. That's what they mean. Go in the other direction. 1, 2, 3, 4, 5, 6, and 7 again over here. It's minus 7. Okay, those are the A values. It's on the x-axis. The B values, plus or minus 3. They're going to be up 3, down 3. 1, 2, 3, and then 1, 2, and 3. So, ladies and gentlemen, this is where positive 3 would be, and this would be negative 3. Now, we have to draw a box, and so here's what I mean by that. And I think there is a way. Can I style that? What do I mean by style? Is there a way to style? Stylize, yeah. No, not by color. Disconnected Apple Pencil. No. Not by color. Oh, these are the colors. No, we don't want to do that. I'm going to draw a box here, but I want to draw a dotted box. Is there a way to do that? No. No, I don't know what's that finger for? And what's this for? Hold laser tail. Is there a laser? It's a laser. I don't know. It's just something to play with. What is this? Anyway. Okay, I guess I'm going to have to draw a box, but you know what? Let me do a dotted box. Okay, because that's the idea. So if this was graph paper, this is what I mean. So you start to get spoiled with this stuff. Start to want the iPad to know how to do everything you want it to do, and it just doesn't. So if this is graph paper, this is what I'll be doing. And probably erasing. Okay, here's what I mean. Draw this diagonal. Draw this box here. Now, every one of these boxes has these special kind of points called vertices. The vertices here, ladies and gentlemen, are on the corners here. So on these edges, these corners. There's a vertice. There's a vertice. There's a vertice. A vertice, right? Vertice, ladies and gentlemen. So I want you to locate the vertices here. And we're going to put step 3. Or we're going to say plot the values of A along the x-axis, the values of B along the y-axis to create a box, and then draw vertices, or I should say draw lines. These are called asymptotes. And they should be diagonal lines. Diagonal lines through the vertices, the edges, and I'm going to do that in red. And it has to go through the origin too. So here's my origin. So there's the point, the edges, and the origin. So we're going to draw these diagonal lines here. This is the process. Okay, there you go. And my choice is 7 is in the choice here. Now, this is the frame of my hyperbola, double parameters. Here's the frame. So here's what you guys are going to do. You're going to do 2 sideways parabolas. And it's going to go through that 7. It's going to go, and again, you never would guess my parents are artists. Let me try to draw a couple of these. You get as close as you can to what we call this diagonal axis. It's actually called an asymptote. You get as close as you can, but you never cross. It's like a boundary. And this is a picture of what we call a hyperbola, but specifically it's a horizontal hyperbola. So I'm going to call this here horizontal hyperbola because we also have a vertical hyperbola. You have 2 types, horizontal and you have vertical. So let me clean this up. X squared over a squared minus y squared over b squared is 1. Instead of drawing the oval, you draw a box through those a and b values. And then you draw diagonal lines across the vertices. And then you could draw your double parabola. Let me show you, though, the vertical hyperbola. Vertical hyperbola looks like this. It's of the form y squared over b squared minus x squared over a squared. And that will equal 1. And you do the same steps, but be careful here. This is the equation. Let's look at an example. And you say you can have y squared over maybe 25 minus x squared over 4, and that equals 1. Here's what I mean by being careful. Whatever is under x squared will be always a squared, so that's going to be in red. Okay, so whatever's under y squared, which is 25 here, that's going to be your b squared. So if you notice, we're consistent. We just happen to write the y squared first. There's still subtraction here, and it still equals 1. So this is the equation of a vertical hyperbola, meaning a double parabola, but it's going to open up and down versus left or right. So you call this horizontal because it opens left and right. This is going to be vertical. It's going to open up and down, but we have to find the values. So I would say again, remember, a squared is 4, which means a will be plus or minus square root of 4, or a is plus or minus 2 by solving that square root formula. Similarly, I have b squared is 25, which means b will be plus or minus square root of 25, or b is going to be plus or minus 5. And so it's going to be the same process. We found the a and b values. So remember, a values go on the x-axis and b values go on the y-axis. And I want to make sure I have enough space. So here we go. X-axis, y-axis. The a values, 1, 2. See, that always goes to erase. 1, 2. There we go. And then -1, -2 right here. 2, -2. And then your b values are going to be 1, 2, 3, 4, 5. And I'm not going to do it to scale. I'm going to say this is 5. And this is going to be -5. It's not to scale. It's a sketch. Draw your box, right? So this is what I would do on graph paper, or we used to do this on graph paper. We draw the box, and actually we would use rulers. And I thought this had a ruler somewhere. No, maybe it doesn't. Sorry. Thinking of another program. Let's go to the vertices. Here's my corner. You're going through the origin. Okay. Going through the corner. And remember, draw this imaginary diagonal line that your hyperbola never crosses this imaginary line. This is called an asymptote. And technically diagonal asymptotes. Okay. Remember what we said here. This is vertical. Vertical means up and down. So what you'll do, starting at that 5, you're going to sketch a parabola that opens up, and it never crosses that diagonal. And that one opens up. It's a double parabola. It's a hyperbola. This will open down. We got double. We crossed. Can't do that. You never cross that diagonal line. It gets close, but never crosses. So here's a sketch, ladies and gentlemen, of what we call a vertical hyperbola. And that's just the process that you go through over and over again. So, ladies and gentlemen, this is what I'm going to have you guys work on here for some of these. And then I'm going to say, I'm going to go back to the circle. I'm going to go back, give you something here, give you a note. The equation of a circle I gave you is x squared plus y squared is r squared. And that's a circle. We have a center is at the origin. Okay. The radius value is always positive. Now, we have a general equation of the circle. X minus h squared plus y minus k squared is r squared. Now, this is the very general equation of a circle. And as you can start to guess, if you go back and you thought of what you did here with the parabolas, you had a vertex at h and k. But here, it's a circle. It's not a parabola. The center is going to be at h and k. The radius, again, is positive. So you're going to have to find that radius value over here. You're going to have that r squared again. But this is the general equation of a circle, but the center now is not the origin. The center is going to be at another point in the plane, the coordinate of which is hk. So we can start to, draw circles that are off center. And this is what I mean. So for example, we're going back to the circle. And they will say, here you go. You have x minus 1 squared plus y minus 3 squared equals 25. So you have the equation of a circle. You might say, well, how do I know? Well, you got the square. You have plus. You have a constant there. And so you say, oh, this is my r squared. So ladies and gentlemen, we already know that if r squared is 25, r is plus or minus square root of 25, which is plus or minus 5, r is 5. So here, ladies and gentlemen, we know the radius of this circle. The question now, this is what's new. What's the center? It's h and k. You say, well, what's h? H is the number that goes here. Remember this? It's after that subtraction sign. After subtraction sign is a 1. So my center, ladies and gentlemen, is 1, comma, k now. This is h, and this is k. And you might say, well, what's k? K comes after the subtraction sign, just like H, because it has Y minus then K, like X minus then H. So in this case, this will be 3. That's my center now. So it's just like finding H and K for the parabola, ladies and gentlemen. So my center is not the origin. The center is 1, 3, and my radius is 5. Now you say, well, what do we do now with this information? Well, let's bring in our picture here, Cartesian coordinate graph. Import it. I'm going to move it here. All right, let's try this out here. My center is 1, 3. So let's find the center. You go to the right 1, and then we go up 1, 2, 3. So ladies and gentlemen, this is my new center. So you first plot the center. So remember, when we actually draw a circle, we need the center. It used to be the origin. It's no longer the origin. It's 1, 3. And then we have to use the radius now of 5. So you might say, well, how do we do that? Well, here's what you do. From that new center again, you have to go to the right. 1, 2, 3, 4, 5. And you also have to go to the left 5. 1, 2, 3, 4, 5 again. So I go from the center, the address being now 1, 3. I go to the right 5. I go to the left 5. And since it's a circle, not an ellipse, I go up 1, 2, 3. 1, 2, 3, 4, 5. And I go down 5. 1, 2, 3, 4, 5. So ladies and gentlemen, you actually are starting to see the shape there of your circle. We just have to sketch it now. So just like before, we have to find H and K, the center, and we have to now use the radius, and it's constant. To the right, left, up, or down, it's 5. Now, the good news is, I hope, it's not a good circle. Yes, it actually drew. Let's see how it did it. Did it do it okay? Let's see. Try to line it up. Maybe a little higher. Come on. There we go. There we go. Looks something like that. Now, we don't have to find the other coordinates here, but the point I'm making, ladies and gentlemen, is you have a new center. It's right here. Address is 1, 3. The radius here is 5, so that the distance, from the center to the edge is 5 units, and it doesn't matter which direction. This is how you graph circles that are off center. So here we go. If you take a close look, that's what's happening here. So you have this way to graph these. And of course, you have all those other ideas that come up and they say, okay, Mr. Judge, but what if they give me, x plus 2 squared plus maybe, let's do a y squared, and then that's going to be a 9. You say, let me try something like this out. And what I'll say to you is, this is the general equation of a circle. Because if you look at this y here, you can think of this as y minus 0 squared. So notice you have plus, you have the x and y variables squared, and then that equals a number. It equals a constant out here, right? It equals 9, and that is your r squared value. So altogether, you can say let's find the radius. R squared is 9. You're going to follow the same exact procedure, right? R is plus or minus 3. The radius is always positive. It's a circle. There we go. R is 3. And then you go back and you say, but I thought you told me, just like for parabolas, the general equation will be x minus h and y minus k. You're going to say, I thought, here's the minus sign. Here's my minus sign. The h and k values are always what comes after that first minus sign. And it does. So we're going to have to write this as x minus a minus squared because you have plus. And remember, here's that first minus sign. Minus a minus makes that a plus. So the center, ladies and gentlemen, of this circle, the h value here, is actually -2. There's my h value. Since I have minus here, what comes after the minus is 0. This is my k value. So it's -2, 0. This is the center. It's not the origin. So I have all the information I need so that I can begin to sketch this curve. We just have to bring in the graph. Okay, so the center is at -2, 0, and the radius is 3, so we have to plot the center. -2, go to the left. 1, 2, there you go. -2, 0 is right here, ladies and gentlemen. That's the address. Here's the center of my circle, but the radius value is 3. So what that means is I'm going to go to the right and left 3 units. 1, 2, 3. And to the left from the center. 1, 2, 3. It's a circle from the center. 1, 2, 3 units up, and then 1, 2, 3 units down. Because it's a circle. You go to the right, left, up, and down, the same value, constant value called r, and it's 3 in this case. So we get to now draw our circle. And I like that. It draws a circle. Just have to bring it over. There we go. And up, maybe, can it? Anyway, that looks okay. I mean, a little bit. There we go. Maybe something like that. Okay, so there you go. Center at -2, 0, radius is 3. So that's how we go about finding some of these values. And then let's give you a trick one again. Say, what's a trick? Let's say x plus 4 squared plus y minus 3 squared. And then that equals maybe, is it a trick? I don't know if this is a trick. If I said to you 10. Okay. This is the equation of a circle in general because of the fact that you have here 2, 2, plus, and then you have this r value here, or r squared, I'm sorry. R squared is 10. This is r squared. So it's in the general form of a circle. R squared is 10. R will be plus or minus square root of 10. R is approximately plus or minus. Let's find the square root of 10. To the nearest tenths. We're going to go to the tenths, right? So the digit 1 in this decimal place, 1 to the right of the decimal is the tens position. The next digit is a 6. So that means I add 1 to the 1. So this is 3.1. Sorry, 3.1 plus that 1, that's 3.2. So the radius again is positive, and now numerically it's about 3.2. So we're going to use this to sketch. Let's see what the center is. We got plus, so I have to change this. See, here we go. We got plus minus the minus. That means my h coordinate is -4. Here's h. After the minus sign again for y, I need this is my k value. So the center is going to be, just like for parabola, it's -4, 3. That's my new center. That's the center, -4, 3. So I'm going to use this information to sketch a circle. And that circle is off center. So let's plot -4, 3. Let's plot the center. So I go to the left. 1, 2, 3, 4. I go up 1, 2, and 3. There's my center. -4, 3. I have to use the radius value. I have to go to the right, left, up, and down 3.2 units. So 3.2 units to the right and to the left. Let's say 1, 2, 3, and 3.2 is just a little bit more. Go to the left. 1, 2, 3, and then just a little bit more. Go up. 1, 2, 3, and just a little bit more. Go down. 1, 2, 3, just a little bit more. So I won't do that anymore. It's a weird voice. All right, let's draw our circle. So I like that, I get concerned that the iPad thinks I'm drawing an ellipse and it knows I'm not, which is great. So anyway, take a look at this, ladies and gentlemen. There's a nice off-center circle. The origin is now, or the center we say, is now -4, 3. Radius is 3.2, and this is how we handle the situation where you're off-center. So there's a general equation, and we have the same thing happening for an ellipse that's off-center. You say, what is an off-center ellipse? It looks like this. X minus h squared over a squared plus y minus k squared over b squared. And this is 1. And let's cut this. Let's move this over. Okay, there you go. So for example here, let me write down more information so you guys know. The center, of course, at HK, and there's no radius because this is an ellipse, right? It's an oval shape. So they can give you something that looks like this: x minus 3 squared over 16 plus y plus, let's say y plus 3 squared over 4. And that equals 1. So ladies and gentlemen, here's a few things. Let's go with the process here. Now we get to start by remembering that the constant under the x squared term is our a squared value. That's the x-intercept value. The constant under the y squared term is the b squared value. Remember, this is an ellipse. And that's where we start, we identify the a squared value, the b squared. It's always the case. So, I mean, take a look. B squared, and this is a squared, right? It's under the x, like this is under the, let's find the right color. It's y there. So we find the a squared and b squared values. Let's just find those numbers here. Let's show you how we do this. This is a squared is 16. They're not going to be intercepts anymore, though. I'm going to show you what I mean by that. And a is plus or minus 4 here. Similarly, we have the b squared. So we say b squared is 4. B is plus or minus square root of 4, or plus or minus 2 for b. So there you go, ladies and gentlemen. A is plus or minus 4, b is plus or minus 2. We're going to use these values here. But we need to know the center. Now, the center always comes after. We need the h and k. So there's minus, and go. We say, oh, okay, good. Then the number 3 here is that's my h. So center, h is 3. And then you say, but I have plus here. I don't have minus. So this is y minus a minus. So my minus sign and the k value is after. So that means k is negative 3. Just like the parabola. So here's my center. So ladies and gentlemen, there you go. You have the center and you have your a and b values. Let's see how we use this now, right? Remember, this is an ellipse. You got plus there and it equals 1. Okay. So let's bring our graph in. Well, that's weird. It doesn't want to come in. There we go. All right, so we're going to bring this graph in. We need to plot the center. Center is going to be at 3, negative 3. So let's try to plot that. The new center. 1, 2, 3 to the right, and then 1, 2, 3 down. This is 3, negative 3. That's the new center. Okay, so remember what we do now here. These a values of plus or minus 4, they were x-intercepts. They're not going to be that anymore. We just need to go to the right from the new center. 1, 2, 3, 4. And to the left. 1, 2, 3, 4. And these are the a values, so they're no longer intercepts. Like when it's off center, it changes the language there. Your b values are plus or minus 2, so I'm going to go up and down 2. You say from where? You do it from the new center. So you go up 1, 2, and then you go down 1, 2. So from the new center, the b values are plus or minus 2. We already found them here in green. You go up 2, you go down 2. And now you just draw your ellipse, your oval. Not really an oval, but it's kind of interesting how, yeah, I think that's a trapezoid, sorry. No, I keep saying trapezoid. Polygon. Yeah, it's not so smooth, so I'm going to do this. There, now it thinks we have an ellipse, but I have a little diagonal to it, so it would help if I can. There we go. That's a little bit better. There we go. Something like that. So that's how we deal with these off-center ellipses, ladies and gentlemen. It's the same process, like a circle. And then let's give you an interesting one. Let's see how you guys handle this one here. I mean, maybe not so interesting. I don't know. Should we go there? Really interesting? I don't know. How about this? X plus 2 squared plus y squared over 5 equals 1. Very interesting. Okay, I'll give you a little hint. I'm going to have to put this over 1, right? Because anything over 1 is itself. But maybe we should color it something else so you guys know it's not always given to you. Let's do orange here. So I would use red, but there you go. Now, remember what I said. A squared is always the number under the x squared term. So a squared here, ladies and gentlemen, I know I covered it up. A squared is 1, which means a is plus or minus square root of 1. A is plus or minus 1. So I got the a value. Now, in green, we've been saying under the y squared term, in green, that's a 5. So we say b squared is the value 5, which means b will be plus or minus square root of 5. And let's find this out numerically. And since it's an irrational number, we're going to have to approximate. We need to know the approximate square root of 5 here. I don't like that calculator. I like this one. Square root 5 and approximate to the tenths. That's 2.236. So 2, that first 2 is the digit. Look to the right, it's a 3. So we leave the 2 alone. 2.2. All right, we just need the center. And you say, this is tricky. They put minus the minus 2 squared. And over here, you got y by itself. Well, that's y minus 0 squared. So here's your first subtraction. And h is the number that comes after. So here's a negative 2, and here's a 0. So your center is going to be negative 2 comma 0. That's your new center. So you have a center, negative 2, 0. We got the a and b values. We're going to draw this ellipse. Let's try this out. Ladies and gentlemen, let's bring in a graph. Negative 2, 0. So we're going to plot that center. Go to the left 2 units. Left 2, not up and down. There you go, negative 2, 0. It's my center. Now look at the a value in red. A is plus or minus 1. So I'm going to go to the right one from the new center and to the left one. Oh, this is kind of interesting. And then for b, look at that. We're going up 1, 2, a little bit more, 2.2. Go down 1, 2, a little bit more, 2.2. And we now get to sketch this ellipse. So I'm going to kind of make this bigger so you guys can see that here. I'm going to try to sketch an ellipse this way. I knew it. It's thinking that's a nice polygon. All right, let me try to be smooth. There we go. I convinced it that it's really an ellipse. And oops. And I don't know. Okay, maybe something like that. All right, let's try to move out there. So take a look all together. This is sketching the ellipse. Right here. There's your values, information you use. All right, so now what I'm going to do, I'm going to check something really quick here on my website because I have some ideas in my head that I want to look at. So here's what class 125. And I'm looking at conic sections. This is the stuff we didn't get to today. And yeah, let me try something here. Okay, you guys might like this here. Here's an example. They have x squared plus y squared minus 8y. And I know there's a typo in this one, so let me try to find out where it is. Let me do something. I think this one's okay. If there's a typo, I'll change it on you guys. Okay? So if you look at this example here, they want us to graph this. They want us to sketch this curve. And so the question is, how do we do that, right? You're looking at this and you go, boy, that doesn't look like it's the equation of a circle. That doesn't look like it's the equation of an ellipse or a hyperbola. That doesn't look like anything I've seen. And you're right. It doesn't. But let me express this to you guys here. You're going to use a process called complete the square. So if you guys were here, I would ask you, have you ever seen complete the square before? And you'd say, yes, you've seen it in solving quadratic equations. You've seen it in, boy, I guess we're going to see it here again, right? You've seen it in graphing parabolas. You're going to see it in graphing conics here. So what you now have, I want to be specific. Notice this. You say, Mr. Judge, how am I going to complete the square? Where's my b value, by the way? Well, the b value is over here. Here's my, see this variable y? You got a y squared, right? So you're going to complete the square with respect to the y variable. And you say, why, Mr. Judge? Because that b value you have here, that's the by value. There's no x value. So if there was an x value, you would complete the square in terms of x. There is none. There's a y. It's linear in y, that term. So when you complete the square, it's going to be right there for the y variable, which means my b is -8, and I divide by 2. We get -4 for the first step. -4 squared is +16. So those are the first 2 steps and complete the square. Now remember, you copy everything down. You got x squared, you got y squared, minus 8y. Here's where you leave the space, ladies and gentlemen, because we're completing the square with respect to the y variable right in here. All right? That's what you're doing, because you have a linear term. You got that 8y. That's really a minus 8y. So like we did before in completing the square, you're going to take that 16, you're going to add it, and you're going to subtract it like you did before. But only this time, since we're completing the square with the y variable, remember that, I'm going to say here, you're going to factor those 3 terms. And here we're going to add. So this process is the same. We didn't do anything with the x squared. So it's the same process, but I'm completing the square with respect to the y variable. So I get x squared plus, remember, don't really factor. Use the value found in step 1. That's a -4. So I'm going to use that value here, -4. And then over here, you say, aren't I supposed to add? I get -16 plus 15. You do. And what is that? That's -1. and that equals 0. And so at this point, people say, oh, Mr. Judge, I kind of don't recognize this. It's starting to look familiar. And I'll say, you know what you should do? Now add 1 to both sides. So this will equal 1. So here's the equation here, ladies and gentlemen. So the question I have for people here is this. If you were here, I'd say to you, what equation is this? Remember, we're talking conic sections. It's either a parabola, a circle, an ellipse, a hyperbola. So which one will it be? Anybody know? Remember, I'd hit the sound. Where's my sound? Let me find my sound here. Right? And ask you guys, what will it be? Anybody know? What is that going to be? And then sometimes people don't say anything, and I have to ask again. Any response? What's it going to be? And if nobody answers, what do I usually do? All right. If you said it was a circle, you are correct. And then I'm going to say to you, okay, since it's a circle, where is the center going to be? And if you said 0, 4, you're correct. And then I'm going to ask you, then what's the radius? If you said 1, you're correct. You say, well, how do we know? Because this is x minus 0 squared. That's just x squared. Here's that minus sign. H is 0. K is 4. H value. K value. And then over here, r squared is 1. So say if r squared is 1, square root formula, r is plus or minus square root of 1. R is plus or minus 1. R is positive. R is 1. This is why, ladies and gentlemen. And so what you would do, of course, is you would sketch your circle. I'll do the whole thing here for you guys to see. You'd bring that in. Center is at 0, 4. So let's find 0, 4. 0, just up 1, 2, 3, 4. Let me make this bigger. There we go. 0, 4, ladies and gentlemen. I don't know what that is. Oh, come on. It doesn't like that. Okay. Let's erase this and start over. 0, 4. 1, 2, 3. Here's my origin. What do we say the radius is? 1. Okay, oh, that's interesting. So I go to the right one. Here we are. Go to the left one. Go up 1. Go down 1 from the center. And I'm now able to sketch a circle. Hopefully I want the iPad to sketch it. Yes. There we go. Center 0, 4. Radius is 1. That's what it looks like, ladies and gentlemen. All this detail together. But notice what you had to do first. You had to complete the square for the y variable. So this is the work you do. Compare that to example. If you had x squared plus y squared minus 4x And I'm going to put minus 5 equals 0. I think, let me double check. Yeah, minus 5 is 0, ladies and gentlemen. You may say to me, I don't know what that is. There's no equation that looks like this. I don't know. I don't remember anything like that. And I'll say, I understand. But for this problem here, if you notice, you do have a bx term, right? Sorry. We have a bx term. So what I'm going to say here, first write it this way. Put the x variables next to each other, because when you complete the square with respect to x, it'll make things easier to work with. So I put the x variables next to each other because, again, we're going to complete the square. And it's for the x variable, because we have a bx term there. So there's that b value. So step 1, we say negative 4 over 2 is negative 2. And step 2, we take the negative 2 and we square it, and we get positive 4. And step 3 is the write down step, right? So you have, let's keep some space. Remember that? We got to have some space. So we're going to put plus y squared minus 5 is 0 here. So here's our space right here, because we're going to use, like we always do, the value found in step 2. We add 4. We take away that 4. And yes, the first three terms we factor, and the last 2 we add, but we don't really factor when we complete the square. X squared, right? I'm going to find purple, that negative 2, the value found in step 1. So negative 2 goes over here. And then we have, when we add, let's do the addition now. So let's take a look at this so you guys can see this here. You got negative 4 minus 5. And you have y squared. So the terms that are like, you're going to have to put down here the y squared. And negative 4 minus 5 is negative 9. And then that equals 0. So ladies and gentlemen, you're almost there. All you do now here is add the 9 to both sides. And just like the prior example, you have x minus 2 squared plus y squared is 9. This is the equation of a circle, because it's in general form, if you guys remember. X minus h squared plus y minus k squared is r squared. It's general form. Of course, y minus 0 squared here. 9 is at r squared. So if r squared's 9, r is plus or minus square root of 9, r is plus or minus 3. This isn't an ellipse or hyperbola. R has to be positive. So r is 3. And you say, where's the center? Center is h and k. So minus, the values after the minus. This is a 2 and this is 0. So 2, 0. Center's at 2, 0. So 2, 0. There we go. Come on. Okay, 2, 0 is the center. So let's go to the right. 1, 2. There we go. There's our center. We can put the address. 2, 0. Now the radius is 3, so I'm going to go to the right 3. 1, 2, 3. Go to the left 3. 1, 2, 3. Go up 3. 1, 2, 3. And go down 3. 1, 2, 3. Draw your circle. And I'm just so grateful that the iPad knows what I'm trying to draw. Okay, very nice. It looks pretty good. So that's what we have to do. Notice here, you had to complete the square. That's all the work. You had to complete the square, ladies and gentlemen, from the beginning, this time in terms of the x variable. Now, just to kick this up, let's see what we do with this one. X squared plus y squared plus 6x plus 4y plus 12 is 0. So if we have to graph this again, and we look at it and we say, oh, okay, what is this? Well, I don't know, but let's take a guess. Let's complete the square like we did in the prior two examples. But this time you say, well, with respect to what variable, Mr. Judge? I see a 6x, which means I have a bx term. And I see a 4y, which means I have a by term. I have two linear terms. One for the x variable and one for the y variable. So when you say complete the square, since I have two linear terms, I'll say with respect to both variables, x and y. So you're going to have to do it, ladies and gentlemen, for both. So remember what I did before, right? I put the variables. I'm going to put x squared plus 6x. The x's together. I'm going to put the y's next to each other. So it's y squared plus 4y. Don't forget I have a 12 there, and that will equal 0 here. So I'm going to put the x variables together. I'm just rewriting the terms in the y variables together. So when I complete the square, here's what I want you to focus on. This is what I'm completing the square on, these two. So for the x, first step is 6 over 2, which is 3. Second step will be 3 squared, which is 9. For the y variable now, 4 over 2, which is 2. And that's the first step. Second step, 2 squared is 4. So here's what you do now. Leave some space, right? Because you're going to add here and take away the 9. So we add 9, take away 9. That's just for these two. And then you have the y squared plus 4y, leave some space. Same thing. You're going to use that 4. Add 4, take away 4, and then don't forget, you're left with this plus 12 still. It's still there. You got the plus 12. And that equals 0. So, ladies and gentlemen, the first three terms we factor, and the first three terms here we factor, but not really. If you guys remember, that'll be x squared. This will be y squared. Notice the constants, though. Notice what you add here, what you combine. You got the negative 9. You got the -4 and the +12. Okay, so I'm going to put that down now. -9 minus 4 that's -13 plus 12. You got -1 here, ladies and gentlemen, and that equals 0. Don't really factor. Let's get out the purple. Because for the x variable, 3 plus 3. 2 for the y variable, plus 2. So we're almost there, ladies and gentlemen. If you just add 1 to both sides, like you've been doing, you obtain this x plus 3 squared plus y plus 2 squared is 1. So here's the equation of a circle again. So we didn't know what it was. We completed the square for both variables because you had 2 linear variables. And now you have the equation of a circle, where the center, ladies and gentlemen, is going to be at -3, -2, with a radius of 1. -3, -2, radius of 1. So when you go to graph this again, insert the graph. Find your center, -3, -2. So you can go to the left. 1, 2, 3, and go down 1, 2. There's a new center. -3, -2. Now you have a radius of 1. So that means I go to the right 1, left 1, up 1, and down 1. All right, so let's see this here. Let's kind of blow this up. This is what we're looking at. So let's draw a circle. There we go. So there it is, ladies and gentlemen. There's your radius 1, center at -3, -2. Right? In fact, all of this here is the work you had to do. Maybe we got to make it smaller. This is the work you had to do to sketch that circle. So yeah, so we're going to complete the square. So what I want people to do on the homework here now, what you guys will do, I'm going to give you guys at this time the following. You guys are going to graph. I'm going to say to you guys for tomorrow. Yeah, I'm going to say 48. So here's what you're going to have for homework on the web. It's part of your homework. You're going to go do the web work, and you're going to work on conic sections. And that's, of course, graph conic sections. And you're going to do 1, 2. What did I do? Yeah, 1 to 48 all. Okay. So you can do 1 to 48 all for homework. So get started on that now. And of course, I'm going to do all the things I said I would do, and I'll contact you guys in Canvas. But I'm going to try to get this video uploaded for you guys, and hopefully you guys find it helpful. And I'll communicate with you guys on Canvas, okay? So thank you guys so much.